So what we're going to be doing today is looking at maximum and minimum problems. This is sort of a precursor for calculus, because a lot of what you do in university calculus is trying to find the maximum and minimum of certain functions. What we're going to be doing is looking at parabolas. Now, depending on your parabola, some parabolas go down like this, some parabolas open up like this. This parabola here has a maximum point, but no minimum point. And this parabola here has a minimum point, but no maximum point. Okay? Each of those green points, can they go sideways? Yes. There are sideways parabolas, but we don't work with them this year. It used to be that they put sideways parabolas into the grade 12. They've taken it out of the grade 12. So now if you go into university, you might hit a sideways parabola. All you have to do is switch your x and your y. So if you have x equals y squared instead of y equals x squared, you'd have a sideways parabola. Some calculators you have to just switch the way that it's equal to. There's an x equals toggle. Anyways, so we have our maximum and our minimum, and you notice, where do those happen? What point is that called? What's the special name for that point? The vertex. So if we can find a vertex, we can solve maximum and minimum problems. So our first one that we're going to look at are height problems. These are the easiest ones because they give you the equation. Find the maximum height of a ball thrown from one friend to another if its path follows this. H equals negative 2t squared plus 4t plus 9. H is the height of the ball, and t is the time after it's thrown. So we need to find out where the maximum is. Now, if we imagine this is a parabola. The ball is going to go up in the air and then come back down. If we can find that point, then we'll be able to say what the maximum height is and at what time it happens. For all of these, we're going to solve them by completing the square. Because if we think about our parabola in this form, if it's in this form, you know what the vertex is, because the vertex is p comma q. So we have the equation. Instead of y equals, we have h equals negative 2t squared plus 4t plus 9. So how do we complete the square? We factor that negative 2 out of the first 2, leaving us with t squared minus 2t. Keep the plus 9 outside. So we're changing it to standard form. Leave some spaces. What goes in that space? First space will be plus 1. Second space will be plus 2. Because when we add that first plus 1, it's going to get hit by this negative 2, so we've actually subtracted 2. So in order to compensate, in order to make sure that it goes away, we have to do the opposite of adding 2. We have to subtract, opposite of subtracting 2, we need to add 2. And now, we've changed it to the standard form. And our vertex is 111. So what does that mean in the context of this question? The ball was thrown from one friend to another. H was the height, t was the time. Okay? And in this case, the t is where our x's normally were, and the h is where our y's normally was. So this is our time, which is going to be 1 second. And this is our height. And in this case, it's going to be our max height, because that's our vertex. And because our vertex is opening down, we would have a maximum. Our max height at 11, I think it was in meters, right? Height, the ball in meters, time in seconds. So after 1 second, this ball gets to its maximum height at 11 meters. Now the height questions are the easiest because an equation is usually given to you, as it was in this case.